Hello everyone, my name is Saili Kadam. I am a MSc Scientific Computing student. I have always felt that the concepts like machine learning, artificial intelligence are always taught in a very complex way. So through this channel, my aim is to explain the concepts such as machine learning, artificial intelligence in a simple manner so that anybody can understand and learn machine learning. So to start with, today we will be introducing the basic concepts of machine learning. So to start with, what exactly is machine learning? So have you ever wondered, like whenever you search something or whenever, let us say, you simply searched a song, you listen to that song, and then again you will start, like you will observe that you will get multiple such recommendations of the similar song or same type of songs. You will get multiple recommendations, right? If you see some news or something like that, you will start getting videos like that. So how does this happen, right? Again, if you searched a product, okay, you try to search a product, you are planning to buy something. For that reason, you simply searched a product, then you will observe that you will start getting advertisements of the same similar product, or you will start getting some recommendations or the basically the offers going on the similar product, right? So how does all of this happen? So if we try to do this manually, how, like, do you think is this possible manually? Because as the number of users increase, things start becoming very complex, right? So recommending like an algorithm that simply recommend every single thing to every single user, is this doable? Up to some extent that can be done, but as the number of users increase, the things start becoming very complex and are not at all doable. So here is where machine learning comes into picture. So basically, let us say, let us start with what exactly machine learning is. So basically, the computers that we have, so they do the thing that you explicitly make them do. Let us say, I say that if a student has marks greater than 40, the student is pass. Whereas if the marks are less than 40, that means the student is fail. So I have done, like I have asked the program to do so. So it will do it explicitly, right? But let us say I want to build a car, a self-driving car. So is it simple? Like every single time I will explicitly tell that this is to be done? Obviously not, right? So when it comes to recommending something, so as I said, I need to recommend a product to a user. So is it really simple? Obviously not, because there are millions of users. So how long can I recommend manually, or how long I can program so that it will, or the user will get the recommendations, right? So it is quite complex. So here is where machine learning comes to picture. So explicitly programming things becomes complex after a point. Let us say I receive multiple mails every single day. Some of them may be normal mails, but some of them may again be spam, right? Spam mails. So to how will my system recognize that whether this is a the mail is spam or it is not spam? And if we see, every mail has some different format, every mail has some different information in it. There is no specific format, or there is no specific words that may appear, that if this word appears in the mail, it is a spam mail. Okay, the mail is spam. Or if this word appears in the mail, this is not a spam mail, right? So there is no such format, there is no such word, there is no such criteria in which we can identify that whether the mail is spam or not spam, right? So here is where machine learning comes to picture. So basically, I will train, or I will give my system 100 mails that are spam and 100 mails that are not spam, or the normal mails. Okay, so from this, or let us say I give 1000 each. I give 1000 mails that are spam and 1000 that are not spam. So now my system will go through all these mails try to find out the common patterns between both the categories, right? So if the mail is spam, this type of words are coming again and again, or if this is not spam, then this is coming, or this is the format. So my system or my model will try to find out what are the words, what are the formats, what are the patterns in it, right? And then it will make a prediction. So if a new mail comes, so based upon the previous learnings, my system or my model will identify whether the mail is spam or not spam. So this is basically machine learning, that when we try to train our models or try to make our computers learn from some data and predict something or make some decisions. This is basically machine learning. Here you don't need some explicit programs. Okay, so explicitly programmed things can work so well up to a point, but when the data becomes very huge, when the number of users increase, right, at that time programming everything becomes complicated, and there we need some automatically doable things, right, or something that can automatically do the things, right? So here is where machine learning comes to picture. So why should we learn machine learning? So there are multiple reasons. Like, do you know maps? Right? Everybody use maps these days. So on weekends or something, the maps automatically it tells you that this road is crowded. So how does map know this? That this road will be crowded, right? So is in some previous days or like last weekend or so, based on the previous data that it had, based on that it can say that now, so it has observed, it has come up with that pattern, that when it is a Saturday or a Sunday, at that time this road becomes crowded. So there is a very high probability that even today, like if it is a weekend, the day or the if the day is a Sunday or a Saturday, then there is a very high chance that the road can be crowded. So this recommending or just predicting something, right? So let us say I want to invest in stock market, right? If I'm simply considering a shares, and I simply want to invest, I want to buy a shares or something like that, how will I make that decision? Obviously I will analyze the previous trends, right? How this stock has performed in previous 1 year, and then my model will give a prediction that how it may perform in coming days or coming months, and then I can make a decision whether I should buy this stock or not, right? So everywhere, like if I am buying something, right, if I am continuously searching something, so there is a very high chance that I may buy that product, right? So that product should come to my feed again and again so that I may buy it, right? So all of these things, it comes like out of machine learning, or we can simply use machine learning to train the models and come up with this recommendation systems, right? So here there the use is so vast, right? Then let us say I have around 100 or 200 mails, and I'm manually trying to find out whether the mail is spam or not spam. So obviously it will take hours to come up with the thing, right? Right, this mail is a spam mail, this is not a spam mail. So it may take around like 1 or 2 hours, right, to come up with that 10 mails are spam, others are not. Whereas if I train a model that automatically does this, then obviously that can be done within minutes, right? So when it comes to automation, we need machine learning, right, to automate things, right? And then we can easily make decisions. There are multiple organizations, there are a lot of organizations where they have millions of users. Let us say I owe a company, I am trying to I have a product based company, and we are planning to launch a new product. Okay, so to understand it, whether I should launch it or not, if I launch it, whether I will get customers or not. So what will I do is I will try to analyze what are the things that my existing users are interested in, right? So for that reason, again, if I manually start working on it, it will take months to come up with that, whether I should come up with this or not. Whereas if there is a model that can easily analyze my users, their interest, and come up with the decision that you should launch this product or not, right? So in predicting, in automation, and in decision making, machine learning is very important. And the most important application, or the most important reason why one should learn machine learning, that I feel is, today everyone is talking about machine learning and artificial intelligence. Every single field, like today they are trying to implement machine learning in some way, right? So everyone wants to use machine learning today. Everybody wants to, like, whether it is a healthcare sector or a finance sector or research, everybody wants to use machine learning in some way, so that performance increases, things get automated for that reason. So, like, machine learning is getting expanded, like the fields, like every single field today it wants to use machine learning. So this is a good enough reason to learn machine learning. Then there are multiple advantages, as I said. So basically you can, like, the rely we need not to rely on humans a lot now, because humans take, they take time to come up with something or come up with a decision. Whereas this, when we try to automate things, they can be done in minutes. A thing that a person can do in hours, the machine can do that within minutes, right? So for that reasons, the decision making ability that models have. So due to all of these reasons, these are all advantages of machine learning, so we are using machine learning. So it has some disadvantages as well. So the disadvantages is that you need a very large amount of data. If you are trying to build a model, let us say you are trying to build a prediction system, okay, what will be tomorrow's weather, right? So if I just have the data for of last 2 weeks, will that prediction be good enough? Obviously not. But in if I have the data of last 1 month, in that case my model may predict things more accurately. So these are so basically, if you want to build a machine learning model, you need to have a very large amount of data so that the model learns out of it and performs well. So when we are trying to train our model, it obviously requires a very resources, very huge amount of resources and hardwares. So for that reason you need cost, that won't come free, right? So for that reason we need some money, we need that cost. So basically the cost gets increased when we are using machine learning, right? And let us say I have a huge amount of data, but most of the entries in that data are not correct, they are incorrect, right? In that reason my model will be trained, but the predictions made by the model, they may be biased, they may not be correct. So we need to make sure that we have a large amount of data, also the data is correct, so that there are limited errors or less errors. Okay, these are the disadvantages of machine learning. So now we have a bigger picture, that I need to build a model which can make its own decisions, right? So that it can help me in different ways, right? To analyze things, to recommend some things. So now I have the bigger picture of machine learning. So now we have one aim. To achieve that aim, we can have multiple paths, right? I know what I need to do. I know where my destination is. To reach that destination, I may have different paths. In the same way, we have different paths here or different types of machine learning. All of them do one, like the working is same. I need to predict, I need to build a model that will predict things for me. So the aim of all these types are same, but still we have different types, which like as we move further, we will study them in detail in upcoming videos. As of now, we will just go through, we will introduce all these types. So first type is supervised learning, then comes unsupervised learning, reinforcement learning, self-supervised and semi-supervised learning. These are different types of machine learning. So let us understand what exactly this learning types of different types of machine learning are. So first one is supervised learning. So let us take an example and understand. Let us say that let us say we have a student. A student is learning, right? A teacher, a maths teacher, let us say, maths teacher gives questions like addition 10 questions are given to a student along with its answers. So now a student has questions as well as the answers, right? Now my model or my student, the student will go through these questions and the answers, and it will come out that when I add, so it will learn that when I add this to number, this is the output. So I have the questions, I have the answers. Now when the similar type of questions will come, so now the student knows how addition works, right? It knows that these are the questions. When this operation is performed on this is the output. Now it knows how to reach that output. This is what my model learns, right? So this is what the student has learned, that when I am given with this question, this is how I am going to approach this, and this is my answer. So now the student learns how to add, right? Then when similar type of question is given, right, in exam you won't have exactly the same questions, right? You will have some different questions. So when different questions for addition are given, now my student knows how things work. So it will be able to answer it correctly, or the student will be able to perform addition correctly, right? This is supervised learning. When everything is given to the model, the input is given, output is given, like correct output is given, and when these two things are given, then the model is trying to learn and make predictions. So basically it learns the patterns and then it tries to make predictions. This is supervised learning. Supervised learning is the simplest, like it is very simple, and it is again very easy to understand and implement. So basically the most important thing in supervised learning is we have both the inputs and its corresponding outputs, and when we have both, then the model tries to learn the patterns and then make the predictions out of it. Okay. So we have different examples of supervised learning. So these are the algorithms like k nearest neighbor, then linear regression, logistic regression, SVM. All of them are algorithms that like the supervised, these are all supervised learning algorithms. So again, as I said, that supervised learning algorithms are very easy to understand and implement when we have very limited data set. And in those cases, supervised learning algorithms work so well. But the thing is, when the data set increases or the size of data set increases, supervised learning algorithms become slow. And very important, if there are some outliers. What are outliers basically? So let us say we have 10 entries. Okay, like 1 2 3 4 5 6 7 8, and one of them is 100. So this entry significantly differs from other entries. This is basically outliers. Okay, we have multiple entries and there are some entries which differ from other entries. those are outliers. Okay, so as I said, if I have 10 entries, out of 10 entries, 9 of them are in between 10 to 20, and only one is around 100 or something. So that is an outlier, a data point that significantly differs from other data points. So when we have this outliers in our data set, then our result will get affected, right? The model may not predict it so correctly. So these are some of the advantages and disadvantages of supervised learning algorithms. Then applications are, so supervised learning algorithms are mostly used in recommendation systems. Then like to suggest the products, based as we discussed earlier, how we get recommendation of the products and everything. So mostly in recommendation systems, supervised learning is used. Then is, so to classify the images, right, medical diagnosis. So basically to analyze the patterns, we use supervised learning algorithms, right? Then we have unsupervised learning algorithms. So so let us take the same example. So what was the first case? The teacher gives 10 sums, okay, along with its answers. So 10 questions, they are solved, we have their answers as well. In unsupervised learning algorithms, we simply have questions. We don't have any answers. Okay, this is unsupervised learning algorithm. So basically, the teacher only gives you questions and the student tries to find out their answers. This is unsupervised learning algorithms where we don't know what exactly the output is going to be. Okay, we are simply given the data. The model itself tries to find out what are the hidden patterns, what are the structures in it, the relationship in between data. Everything is done by the model itself. So basically, when we simply have the data, when we simply have questions without answers, when the student tries to find out their answers, that is basically unsupervised learning algorithm. So we don't know whether the output, what is the output. So basically, as in supervised learning, we had a fixed question and a fixed answer, right? In unsupervised learning algorithms, we do not have any fixed, so we have fixed questions, but we don't have answers. Our model tries to find out what the answer will be. Okay. So again, in unsupervised learning algorithms, we have different algorithms like k-means clustering. So basically, unsupervised learning algorithms are mostly clustering algorithms. We will be studying these algorithms in detail in upcoming videos. Now we are simply looking into their introduction. Again, supervised learning has its own advantages and disadvantages. So like previously we had that labeled data, everything was labeled, whereas here we don't have labeled data. So it tries to identify the hidden patterns. It don't need any like everything, it will learn on its own. It's not like supervised learning where you need to give everything to the model, right? So, and the most important thing, supervised learning algorithms works well for smaller data sets, whereas for large data sets, unsupervised learning algorithms works well. And the most important disadvantage is, in supervised learning algorithms, we know exactly what the output is. So we can identify whether the predicted output is correct or not. Whereas in unsupervised learning algorithms, we don't know whether the predicted output is correct or not. Because earlier we had the results as well, we had the output as well. So the comparison whether the predicted result is correct or not. So to identify that, supervised learning algorithms are good. But here the prediction will be made, but whether the predicted result is correct or not is not known, right? So it is less accurate. Supervised learning is accurate, more accurate as compared to unsupervised learning algorithm. So mostly the applications of unsupervised learning algorithms are clustering things. So when we need to cluster, or when we need to find to which cluster something will belong to, we will study that in detail. Here is where we use unsupervised learning algorithms. Then again we have reinforcement learning algorithm. So again continuing the same example, we have a student. So in first case, the teacher gives questions as well as answers. In second case, teacher only gives you questions. In third case, you the student has questions and the student is trying to learn. Basically, it learns on its own. Okay, so answers are not given, right? Here also you don't have any answers, like unsupervised learning algorithm. The student tries to understand things on its own, then it gives the exam. So in exam, if the student writes correct answers, he or she will get marks, right? Whereas if the answers are wrong, then it will not receive any marks or it will lose the marks, right? So this is basic working of reinforcement learning. If so model tries to learn, okay, and it tries to improve. So basically, if I now I understood, if I go by this way for this question, my answer is correct, so I will stick to it. Whereas if I make some mistakes in my exam, then I will try to improve them, right, next time. So basically, if my answer is correct, I get marks, that are the rewards. And when answer is wrong, I lose some marks, that are the penalties, right? So in the same way, the model, it learns, okay, and it interacts with the environment. So it finds out whether the predicted result is correct or not. If the result is correct, it will receive rewards. Whereas if like that, so mostly it is reinforcement learning is used in, like we have the games, like where the system plays, like chess, playing chess. So if our model is trying to learn to play the chess, so it will understand, like if I make this move, this is happening. If I make some other move, I'm losing, or that is coming, it is affecting my performance. So it interacts, the model interacts with the environment. If things are correct, it receives the rewards, and if it makes some incorrect predictions, it has some penalties for it. So basically, when the model start learning by interacting with the environment, that is reinforcement learning. So again, there are multiple examples of reinforcement learning, like Q learning, deep Q networks, etc., which we will be learning further. Again, it has its own advantages and disadvantages. Like it improves the experience of the users, so decision making abilities are also enhanced here. Like a good decision can be made because we are evaluating continuously, so it understand whether it has made the correct prediction or not. When prediction is not correct, you can change it, right? So basically, as I said, the example is playing video games or something. In robotics, mostly reinforcement learning is used. Then we have semi-supervised learning algorithms. So in semi-supervised learning algorithm, it is basically combination, as the name says, semi-supervised. So it is basically combination of supervised and unsupervised learning. So let us say my teacher is teaching me, right? So teacher solves, let us say, out of 10, 4 examples are solved. Okay, so I have answer for those 4 examples, and 6 examples are given for me to solve. So here I have some amount of labeled data, but a large amount of unlabeled data, which I need to figure out the patterns and learn on my own, right? So this is basic idea of semi-supervised learning, that have some labeled data, some amount of labeled data, and a very large amount of unlabeled data. So it is combination of both supervised and unsupervised learning. I know answers, I know output for some amount of data, but large amount of data, I don't know what the output is. So I will learn, or the model will learn the hidden patterns out of it, and it will come out with the the decision or the result, right? Again, it has different examples. So basically, these algorithms, they reduce the dependency on the labeled data, because in real life mostly you will have unlabeled data to work on, right? So for that reason, so it reduces the dependency on the labeled data, right? Again, it has its own applications like text classification, image classification, etc. Then comes another type of machine learning, that is self-supervised learning. Now the student is studying, so teacher has taught him a lot of things, so everything is done, but now the student wants to improve its performance. So what the student will do, it will start to create question papers for himself. So I will intentionally create question paper for my practice so that I improve my performance. Right? This is basically the concept of behind self-supervised learning. So basically this model, it tries to create its own labels. It don't need any user or already or built-in labels, right? Or it don't need any manual labeling. It can create its own labels. So a student creating its own question paper and trying to solve them to improve its performance, right? So that is basically the idea or the concept behind self-supervised learning, where the model, what it does, it creates a, or it tries to generate its own labels. That is self-supervised learning. Again, it has its own examples, its own advantages and disadvantages, which we will be covering in upcoming lectures. In next lecture we will be speaking about the supervised learning algorithms. We will be focusing more on supervised learning algorithms. So this was for this video. That's all, and thank you.